So if you jump out of an airplane, your speed will increase approximately 10 meters per second. So every second, 10 more meters are added. You're just speeding up. It's like you're hitting your accelerator, your gas pedal. It has, most excellent. It has nothing to do with your mass. It has to do with gravity. Very good. What did you say? Say again. It will balance out after a little while. That's where you have terminal velocity. And so now that, except that G is gone. It's zero. I mean, G is still there, but your acceleration has gone to zero. So you're not increasing in speed anymore. It's not saying that you're not moving 230 miles per hour, however fast you're moving, you know, when you're flying, when you're jumping out of an airplane. All right, so that's that one. No, you're fine. Y'all ready? All right. We have a spring attached to something. Okay. Then we put a mass on the end of the spring. If we consider this to be the equilibrium position, or x naught equals 0. And down here, we consider this to be the extension, x final. We're going to have some displacement between the two, delta x, and it's going to go down. This is just x final minus x initial. Everybody with me on that? I have a spring right here. I put a weight on the spring. The spring is going to stretch. That's all I'm saying. Yep, this one is like just a loop, or like a hoop or whatever, a loop that we can attach a weight to. I guess I should have put a little hoop right here too. Okay. So the resonance for this particular system is the following. F is equal to 1 over 2 pi times the square root of K over M, where K is the spring constant. It's basically how stiff a spring is. And M is the mass attached to the spring. So the way we would find K is we would use Newton's second law again. And basically, we would just say that the acceleration again is equal to 0, which implies that the summation of forces equal to 0. That's the action-reaction law. So basically, we're talking about inertia, and then we talk about acceleration, which is Newton's second law, and then the third one, which is the action-reaction. And the forces acting in this particular scenario, of course, you have weight going down here. That's just M times G. And then the spring actually has a restoring force. And that restoring force is called Hooke's law.